Hello, 7th graders. In today's lesson, we're going to practice converting between fractions and decimals. Now, this is something you've done in previous grades, so I want you to see if you can fill out this first page. So pause the video, see if you can figure it out. However, we are going to review it all, so it's okay if you can't. Here we go. Number 1 says, write each decimal as a fraction or mixed number. When we write a decimal as a fraction, we have to think of the place value. So remember, the first digit is in the tens. So if I have 0.1, that's 1 over 10. The second digit is in the hundreds. So if I had 0.12, that's actually 12 hundredths. And then the third digit is in the thousands. So if I had 0.123, that's actually 123 over 1,000. So using that information, 0.7 should be 7 tenths because 7 is in the tenths place. 1.29 is 1 and 29 over 100 because 9 is in the hundredths place. And 12.831 should be 12 and 831 over 1,000. Notice how when it's greater than 1, so there's a number before the decimal. That's just the whole number in our mixed number. Okay, and then we didn't give our number up here, but if I added a 4 here, this would be in the 10,000ths place. So 0.0041 is 41 over 10,000. All right, what do the factors of the denominators have in common? Is this always true for decimal fractions? Notice that they're multiples of 10. And yes, we are almost always going to start with a multiple of 10. So when we have a decimal and it's not repeating, we can almost always start with a multiple of 10 as the denominator. Okay, number 2 says use technology to convert each fraction to a decimal. How we're going to use technology is in a calculator. Yes, in a calculator. This should be the first time you've used a calculator this year. You take the top, the numerator, divided by the bottom. So 1/2 to convert this to a decimal, we're going to do 1 divided by 2. You should get 0.5. Next one, we do 1 divided by 3. You should get 0.3 repeating. You can write that as 0.333 ... However, when we add this bar on top, that shows us that it's repeating. So that's a little more accurate. Okay, 1 divided by 4, you should get 0.25. 1 divided by 5, you should get 0.2. 1 divided by 6, you should get 0.16 repeating. Your calculator will round this up to 0.1, bunch of 6s, and then a 7. Note that just because the calculator ends in a 7 doesn't mean it's not repeating. So the 6 is repeating. It should be with a repeating bar. The calculator just cannot repeat forever. So it should be 0.16 repeating. All right, 1 divided by 10 should be 0.1, 1/10. 1 divided by 9 should be 0.1 repeating. 1 divided by 8 should be 0.125. And 1 divided by 7 should be 0.142857. And from here, it repeats 1428. So actually all 6 of those numbers repeat for 1/7. If you want to approximate it, this little squiggly equal sign is an approximately. You can approximate it to 0.14. That's fine, but this is more accurate. Okay, next question says, compare the fractions in exercise 2 with your fractions in exercise 1. What conclusions can you make? Well, when we went from a decimal to a fraction, it was pretty easy. We just stuck it over a multiple of 10. But when we had a different denominator, the decimals didn't always turn out as nicely. So they're not the same. Also notice as the denominator, the bottom number gets bigger and the top number is still 1, it gets smaller. So like 1/10 is smaller than 1/2. Even though 10 is bigger than 2, 1/10 is smaller than 1/2. Way back when you learned fractions, I hope someone explained this with like a pizza. If I cut that pizza into 10 slices, each slice is a lot smaller than if I just cut it in 2. 1/2 is bigger than 1/10. Okay, last one on this page. Does every rational number have a decimal form that either terminates or repeats? Yes. So if you look at all of the decimals in number 2, they either repeated, so they have the repeating bar, like 1/3, 1/6, and 1/7, or they terminated. To terminate just means to end. We're going to use that when we define an irrational number. So again, a rational number, the definition we used previously for rational number is just that it can be written as a fraction. Another definition is that it terminates or repeats. So that's because an irrational number is a non-terminating, non-repeating decimal. It doesn't repeat, it never ends. So a rational one will either end or it will repeat. Okay, to write 2 1/4 as a decimal, -2 is our whole number first, and then we need to make 1/4 into a decimal. So we're going to do 1 divided by 4. If we do that in our calculator, we should get 0.25. So -2 and 1/4 should be -2.25. All right, 5/11. Again, we could type 5 divided by 11 into a calculator. However, this one says use long division. What a great opportunity to review long division. So we're going to do 5 divided by 11. Now we know 11 does not go into 5, so we need to add a 0.0. 11 does go into 50. The closest multiple of 11 is 44. It goes into 44 by 4. 50 minus 44, there's 6 left over. 11 doesn't go into 6, so I need to add another 0. 11 does go into 55 by 5. Then there are 5 left over. Again, another 0. And then this is again going to be 44. And then there will be 6 left over and then 5. Notice it's 4, 5, 4, 5. This is going to repeat forever. So decimal straight up. We can just stop it here. Ignore that other 4, 5. 5/11 is 0.45 repeating. This is a repeating decimal. Fill in the blank, repeating decimal, which is represented with a repeating bar. So again, we wrote that as 0.45 with a repeating bar. Okay, I am going to let you use your calculator on these next 3. As fun as long division is. So see if you can convert to these into decimals. Remember top divided by bottom. And then play the video back to see if you got it right. All right, -1/5 should be -0.2. 7 1/10 should be 7.1. And -3/11 should be -0.27 repeating. Again, your calculator might round that to a 3 at the end. Please recognize the 27 is repeating and write your answer with a repeating bar. All right, this next example says writing a terminating decimal as a fraction. So which fractions are equivalent to -0.26? Select all that apply. Well, 6 is in the hundredths place. So I know that this starts as -26 over 100. So I know B is equivalent. However, it says select all that apply. So 26 over 100 is not equal to 26 over 10. 26 over 10 would actually be like 2.6. So not the same. And then 0.26 over 100, we know we can't have a decimal in a fraction, so it's not that one. If I simplify 26 over 100, notice they're both even, so I can simplify this by 2. 26 divided by 2 is 13, and 100 divided by 2 is 50. So negative 13 over 50 is equivalent to negative 26 hundredths. So both are equivalent to negative 0.26. All right, you are going to try 4, 5, and 6. Write the decimal as a fraction or mixed number. Again, start with your place value. And then it does say simplest form, so I do want you to simplify. And then we're going to talk about number 7. Okay, so number 4, you should have written 6/10, which can be simplified by 2. So your final answer should be 3/5. Negative 12.48 should be negative 12 and 48 over 100. 48 over 100 can be simplified by 4. So this should be negative 12 and 12 over 25. All right, and then 408 should be 408 over 1,000. Let's see, I know this simplifies by 4. Let's try to start doing that. So it should be 102 over 250. Oh man, this can simplify even further by 2. So you could have just simplified by 8 off the bat. It should be 51 over 125. There you go. Okay, so number 7 says which one doesn't belong? Which one doesn't belong with the other 3? There's actually multiple right answers here. So you can, let's either make them all fractions or make them all decimals. If we made them all decimals, 5/12 is going to be 0.416 repeating. The repeating part only goes over the 6. And then 6/15 is 0.4. So you could, off the bat, say that the second one, 5/12, doesn't belong because it's the only repeating decimal. You could say the first one doesn't belong because it's the only one without a 4 in it. You could say the last one doesn't belong because it's the smallest. Let's see what happens if we make them all fractions. 0.25 is 1/4. And then 0.004 is 4 thousandths, which simplifies to 1/250th. And then 6/15 simplifies to 2/5. So not really much we can do with the fractions. I would say the best answer is that the second one doesn't belong because it's the only repeating decimal. But there are multiple answers here. As long as you explain your reasoning, I think you're good. Okay, last example. You are an astronaut on the International Space Station. The table shows the altitudes of the ISS and 3 other objects in space. Which objects are higher than the ISS? Well, to be able to compare these numbers, we're going to make them all decimals. So down here, well, we have ISS as a decimal, but down here we have the meteoroid height, 393 1/2. So we're going to convert that to a decimal, 393.5. And then we have the asteroid height, 1,184 thirds. As a decimal, that is 394.6 repeating. And then 394 9/10 is 394.9. Okay, if we place these on a number line, notice they placed them down here. The ISS is right here. And the question said which objects are higher than the ISS. The only object that's further to the right, because higher is greater, is the satellite. So, because the satellite is the only number greater. Let's see, what was the satellite's number? 394 and 9/10. So because 394.9 is the only number greater than 394.8, the satellite is the only object higher than the ISS. All right, this one at the bottom, I want you to read and see if you can try it by yourself, and then play the video back to see if you got it right. Okay, a box turtle hibernates in sand at an elevation of negative 1.625 feet. So between negative 1 foot and negative 2 feet. 1 to 2 feet under sand. A spotted turtle hibernates at an elevation of negative 1 7/12 feet. Which turtle hibernates deeper in the sand? How much deeper? So to answer this, we need to make 1 7/12 a decimal. So 7/12 is 0.583 repeating. So I'm going to write negative 1 7/12 equals negative 1.583 repeating. If both of these have 3 digits, that means I can just compare 625 to 583. So 625 is more negative, meaning it is deeper. So the answer is that the box turtle hibernates deeper in the sand because negative 1.625 is less than, it's more negative than negative 1.583. And then it does say how much deeper. Because we're using decimals, we're going to kind of ignore the repeating. So if I find the difference of 625 thousandths and 583 thousandths, I get about 42 thousandths. So we can say about 42 thousandths deeper, or 0.042. All right, please remember to submit your notes to Canvas. This should be under the 2.3 lesson. And make sure you check to see what else is your assignment for today.